Hello friends, welcome to the Basics of Geography series. This is our IS Conclave Institute and I am Rohit Mandan here to facilitate you. And this institute which provide you the basics of on various subjects. So we facilitate the students on various subjects. So in this session we are covering Geography Incubation series for civil services examinations, and especially for those students who does not have so much command on the basics and the fundamentals of the geography. So we are here to strengthen your basics, your fundamentals on geography. So let's discuss. So in this matter and mineral series, we already have covered the what are minerals, how minerals and rock differed, and how minerals grouping can be done, means classification of the minerals in the silicate versus non-silicate minerals. So in this session we will cover the silicate minerals. So for other videos like what are minerals, how minerals form, you can refer our YouTube channel IS Conclave. So in this session we will cover the silicates. So if look at this question, sketch the silicon oxygen tetrahedron and explain how these fundamental building blocks join together to form the silicate structure. So if you look at the silicate structure, so these silicon oxygen tetrahedron are the basic building blocks, and how they interact, how they form, they made a chemical bonding with each other or with other metals or with other metals ions. So this decide their properties like their hardness, no, okay, their softness, their textures also. So all the minerals have the different textures because the minerals have a definite chemical composition. Whenever there is a variations, the properties change and the minerals grouping also change. So let's look at how this works. These are the silicate structure. So we have to understand the silicate structure. So every silicate minerals, we know that, as we know that these are made up of the silicon oxygen tetrahedron. Whenever silicon oxygen bondings, so this is in a which type of bonding between the silicon and oxygen? This is the covalent bonding, and covalent bonding are the strongest bond. Okay, so these covalent bond, the silicon oxygen, they form silicon oxygen tetrahedron. As you can see, this is how silicon oxygen tetrahedron will look like. So these silicon Si, why silicon has a small size? Because silica has shared the 4 electrons and all the electrons are shared with the oxygen. So you can see the oxygen, but still you look at the silicon oxygen tetrahedron, this has a chemical formula. So this is not a chemical element. So this is in a ions still. So this has a 4 minus electrons. So this has a 4 minus, means this basically to make it a very chemically stable, electrically stable, this need the positive ions. This need positive ions. So that means this will make a bonding with other, या तो ये bonding बनाएगा with others tetrahedron, silicon tetrahedron, or with the other metal ions, so to make it chemically stable. So let's look at this. We know that most contain one or more other common elements. Because why common elements? Because to electrically balance. So electrically balance करने के लिए they form a common element, they form a bonding with the other mineral, and this is why the silicate minerals, because of the silicate structures, the variation in the silicate structures, because of the variation in the silicate structure, the silicate minerals have a variety. So there are a variety of the silicate minerals. So why they have a silicate minerals variety, so much variety? Like quartz, this has a very different properties. Quartz, like this has a pure silica, SiO2. This is hard, very hard. Okay, this does not have this like cleavage. Okay, but soft talk, this has a very cleavage. Okay, very soft, sit like mica, fibrous asbestos, fibrous textures. So this is how these minerals have different properties, mineral properties. Now look at this. This is asbestos minerals. This is olivine minerals. Okay. Now look at the silicate structure. We have already seen the silicate structures, how these silicate oxygen tetrahedron, the fundamental building block of all the silicate minerals. Now look at the minerals with the independent tetrahedron, because These silicon oxygen tetrahedrons have the ability to form bonding with other silicon oxygen tetrahedron. If silicon oxygen tetrahedron single-handedly means itself can it electrically stabilize itself electrically stabilized by making bonds with other minerals, not minerals, with other metals. Okay, with a like magnesium and iron. Okay, so this is olivine. This is olivine, green olivine. So when this silicon oxygen SiO4 SiO4 minus, this makes a bonding with the magnesium and iron. Okay, this have a plus 2, this have a plus 2. Whenever they made a bond with this magnesium and iron, they become chemically, electrically stabilized. So this forms an olivine minerals. So when iron and aluminium makes a bond with the silicon oxygen tetrahedron, it forms garnet minerals. So this is how you can see when silicon oxygen tetrahedron make bonding with the magnesium iron, this form olivine minerals. Or when this formed a bonding with the iron and aluminum, formed a garnet minerals, because olivine and garnet both are different minerals, have share different properties, mineral properties. So this is how this independent tetrahedron. So independent, whenever any minerals is formed by the independent tetrahedra, like the olivine and the garnet, they are very dense, hard, and equidimensional crystals. So if any they have an equidimensional crystal in all directions, that means they have a strong bond in all directions. If they have a strong bond in all directions, that means they will lack cleavage. Okay, so if they lack cleavage, means they have a resistance to the weathering. So this is how these silicate structures decide the minerals properties, how they will behave with the environment. Now look at the minerals with the chain or sheet structures. So chain structure, when silicon oxygen tetrahedron share oxygen with the other silicon oxygen. So when two oxygen is shared, so double. When three oxygen is shared, sheet structure, or when four oxygen is shared, this is called three-dimensional structures. So as you can see, independent tetrahedra, single chain tetrahedra, double chain, sheet structure, and three-dimensional. So if you look at this in this direction, oxygen and silicon ratio of oxygen and silicon ratio का क्या होगा? It will be decreasing. Here oxygen and silicon ratio will be आपका 4:1. तो here आपका मिनरल्स होगा olivine and garnet. Here होगा pyroxene group, hornblende. Okay, hornblende. There will you find mica sheet and talcum powder. Here mineral आपका होगा quartz and feldspar. So this is how the independent single chain, double chain, sheet structure, three-dimensional structures share oxygen silicon ratio. And oxygen, whenever there is in a different oxygen silicon ratio, there is in the properties, the minerals share different properties, like the ratio of the oxygen ion to silicon and the ratio of the oxygen ion to silicon ions different in this type of the silicate structures. So thank you. And again, अगर आपको ये वीडियो पसंद आई है तो प्लीज़ लाइक, शेयर एंड सब्सक्राइब जरूर करिएगा। और ऐसे ही जो है हमारी वीडियोस को पसंद करते रहिए, तो हम और भी वीडियोस बनाते रहेंगे। थैंक यू गाइस।